All right, Math 1. This is the homework help for Tuesday. We're finishing some of the problems in the study guide. We're going to start with number 8. It says Marcus wants to exchange his American dollars, USD, to pesos before leaving on a trip to Mexico. Okay. A bank offers 13 pesos for each American dollar. So each American dollar is worth 13 pesos. Okay. The bank charges a service fee, so you get charged $2.50 to exchange money. Okay? The equation, all right, so we're going to write the equation. Let's write the equation first. Okay, so for every single $1, it's 13 pesos. Plus, well, minus the $2.50. So you got 13 X because it's 13 for every American dollar. So if it's $2 American, you're going to say 2 times 13. If it's $4 American, you're going to say 4 times 13. And then minus the $2.50. So this is going to be the equation. Your Y is going to equal 13X. Wait a minute. 13. That's right. Y is the money received. Okay, so that's how much money you're going to get because you have to pay. You got $13 for every single American dollars minus the $2.50. Okay, cool beans. All right. So this is going to be the equation. So the equation is going to be, which one of these is going to be the equation? It's going to be A. Let's get right over it. It's going to be A. Okay. All right. Hold on one moment. Okay. So A, 13X minus the 2. Oh, no. That's not right. That's not right. I did that wrong. All right. So Y is equal to, you've got to subtract the $2.50 from X. That's the amount of money that you are giving you. So it's going to be 13 times X minus the 250 because this is how much American money. So if you gave um, $15, you got to subtract the 250 from it first. Then after you subtract the 250 for every amount of money that you receive, you're going to multiply it times 13. So this is the better answer. So if you give $15, you're going to say 15 minus your fee, which is $2.50. And then whatever's left, you're going to multiply it times 13 because that's how much you're going to get for every American dollar. Okay, so B is going to be your answer here. So sorry. B is your answer, y'all. Okay? All right. Then it says that Marcus will receive. Okay, so we got that part. If Marcus gave the teller, one of these amounts of money in American dollars, he would receive 100 um 182 pesos. So let's plug in 182 here. So we got 182 pesos is equal to 13. Let's go ahead and multiply. We got 13x minus. I'm going to use distributive property and get my calculator out. I'm going to go ahead and distribute the 13 there, or I could just keep it the way it is. I don't have to do that. 13. We got x minus. Okay, so to get x by itself, we're going to divide both sides by 13. Okay, so we got 182. 182 divided by 13. And this gives you 14 on this side. This is gone and you're left with x minus the 250. Okay, so now you're going to add 250 to both sides. Okay. So we got the 14 plus the 250, and that gives you 1650. So 1650 is how much money, how much American dollars? 1650 is how many American dollars? It says Kelly and Mike solved the equation in different methods. Okay, so let's see what Kelly did, and then let's see what Mike did. I'm gonna slide this up just a little bit. Make my screen bigger and slide this up. All right, so they used two different methods to solve. Let's see what Kelly did. Kelly, looks like what Kelly did was multiply. Let's see. No. Because if you would have multiplied, she divided both sides by 2. Okay. Or she divided this side by 2, it gets rid of this. When she divided this by 2, this is this one term. When she divided this by 2, it gave her 2 here. Bring this down. And then when she divided this by 2, because these are 2 separate, then she got the x. So that's okay to do this. Looks confusing, but it's okay actually. It's mathematically okay. She brought this down. Then she used distributive property, 2x minus a 4, bring this down. Okay, that's mathematically okay. Bring this down. Here, it looks like she combined like terms, which gives you the x here, minus the 4, she brought that down. Then she moved the x over here by subtracting 1x, which gives you 3x here. She moved the plus 3 over here by subtracting 3, which gives you the negative 7. So mathematically, that part is okay. She divided both sides by 3. When you divide both sides by 3, you get x is equal to a negative 7 over 3. Looks kind of crazy, but she did everything mathematically okay. All right, let's look at what Mike did. Mike used distributive property, which is what we do. We do this method. We use distributive property, and that's what he did. We use distributive property again here. Okay, then combine like terms. He got that, brought the negative 8 down, bring everything down. Then he moved the numbers over here, and that gave you a negative 14. And then he divided both sides by 7. Yes, he divided both sides by 6, and he reduced the fraction, which gives you a negative 7 over 3. So mathematically, both of them did good. So Kelly and Mike both solved the equation correctly. That is true, because both methods use the properties of equality, where whatever they did to one side, you could do to the other side. That is very, very true. Therefore, both equations were balanced throughout the process. This is very true. Okay? So be careful. That is very true statement. They did use whatever they did to one side, whatever operation they did to one side, they also did to the other side. So it's not wrong. All right. What is the solution to this equation here? Okay. All right. So first thing we're going to do is distributive property. So let's do distributive property first. This is negative 4x. This is a negative 32. This is negative 3x. This is negative 6 equals. This is 6x. This is negative 6. This is negative 6x. And this is a positive 17. Okay? Now we're going to combine like terms. When we combine like terms on this side, we're going to combine these two terms together. That gives you negative 7x. I'm going to combine these two together, which gives you a negative 38. Bring down the equal. On this side, when we combine these two together, that's 0. And we combine this together, that gives you 11. Okay? All right, to get x by itself, we're going to add 38 on both sides. We add 38 on both sides. This gives you a negative 7x is equal to, we got 49. Okay, divide both sides by a negative 7. When you divide this by negative 7, this gives you x is equal to a negative 7. So x here is a negative 7. So that's what number 10 is. What is the solution to the inequality? All right, so that's on the other page. Turn to the next page. Okay. All right, so let's solve this inequality here. We're going to use distributive property first. Okay, so let's do this. We multiply straight across. This gives us 35x over 3. We multiply straight across here. This gives us a negative 5 times 5 is 25 over 3. Bring down the inequality. Okay, this is 11 over 3x minus the 1/3. All right, so now we move the variables to the same side. I'm going to move this one over here. So I'm going to subtract 11 over 3x from both sides. Okay, so the denominator is the same. We got 3 on the bottom. And let's subtract. We have 35 minus 11. That gives us 24. So we got 24 there. We got minus the 25 over 3. Bring down the inequality. This is gone, and we're left with 1/3. Okay? All right, this is going to give me 8x here. Well, let me go ahead and add that to both sides. We're going to add 25 over 3 to both sides. Add 25 over 3 to both sides. So this gives me, this is gone, and we're left with 8 over 3x. Oh, sorry, I'm tripping. 8x. Bring down the inequality. Here, 24, this is 24 over 3. 24 over 3 there. We got, let's do, sorry, y'all. We are going to divide that first, and we got 8 here. Sorry. And divide both sides by 8, and we get x is less than, greater than, or equal to 1. Okay? So that is going to be D here. All right. Let's look at the table. It says which x value will make this relation a function. Remember, in order for this to be a function, none of the x values can repeat. So far, they are all different. So far, this is a function. But if I put 2 here, there's another 2 here. So that's going to make it not a function. There's a 3 already here. That's going to make it not a function. There's not a 4, so 4 would work. And there is a 5 that's already there, so D wouldn't work either. So 4 is going to be your answer there. Okay? Number 13, it says which function f of x is equal to, and we got 1,200 times 1.5 raised to the x power. This is raised to the x power. Okay? It says which measures the number of diagnosed cases of the flu. Okay? All right. It says x, if x represents the days, what is the average rate of change? So that means you have to use the formula y2 minus y1 over x2 minus x1. So think in your mind, you have to think in your mind, you need 2 ordered pairs, okay? So what are they comparing? What's your x and what's your y? In this problem, what is your x and what is your y? It says x represents the days. So we got our 2 x values. Our first x value is day 2. Our second x value is day 5. So now we just need to figure out what the y's are. So in order to figure out the y's, you need to substitute the x's in. So let's use the calculator and substitute the x values in. So we got 1,200 times 1.5 caret key 2 days. And so that's going to give you this for your y value, 2,700. Okay? And then let's do the same thing, but this time we're going to raise it to the 5th day, 5. And that gives you 9,112.5. Okay? All right, so now we got 2 x's and 2 y's. It's x1, y1, x2, y2. So let's substitute, okay? On the top, you're going to get 9,112.5 minus 2,700. On the bottom, you're going to get 5 minus the 2. Okay? So now let's subtract. We got this number in the calculator already, minus 2,700, which gives you 64,012.5 over 3. Okay? All right, so let's divide that by 3 and see what we get. So this is going to give us 2,137.5. So answer here is 2,137.5. That's B. Okay? All right, in which y is a function of x. So which one of these is a function? So far, this right here fails the vertical line test. Do you see, when I move this across the graph, these x values here are going to repeat. So this is not a function, okay? This was not a function. All right, let's look at this one. This is a vertical line. All these x values are the same. Every single last one of these x values on this line is the same. This is not a function, okay? C, some of these x values are the same. It fails the vertical line test. You see how it fails that vertical line test? This is also not a function. Some of these x values are repeating on this graph. This x value on this ordered pair has the same x value as this ordered pair down here on the circle. Okay, they both have an x value of 1. Do you see it? Positive 1. All right, let's look at this. All of these x values are different, okay? Every single last one of these x values are different. It passes the vertical line test. So D is a function. D is a function. Okay? All right, and so this is the homework help video for Tuesday. We have done problems 8 through 14. All right? Okay, keep working if you like to keep working, and I'll do the other problems tomorrow. Have a great day. Bye.